Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, the honorable person by lecture Mr. Agung Nugroho, SST MTRID, and all of my beloved friends. Before I begin my presentation, let me introduce myself. My name is Nida Dhiya'Ulhaq Kahfi. I'm from Radio Diagnostic and Radiotherapy Engineering, Class 1D. Today, I would like to tell you about film screen system. There will be a question and answer after my presentation. The first time, I will start my presentation from Introduction Film Screen System. Second, component of film screen system. Third, basic principle of film screen system. Fourth, conclusion, and last, closing. Ladies and gentlemen, I will start my presentation. Film screen system. Screen film imaging was first introduced into medical imaging in the early 20th century and has been the primary imaging modality until the introduction of digital imaging toward the end of the 20th century. Screen film systems are still the primary imaging modality in many areas. Consequently, it is essential to have a good understanding of the technical aspect of screen film imaging system. Screen film radiograph is the use of silicon film within a cassette being placed behind the object to be imaged and exposed to an X-ray beam. The function of screen film performed by the intensifying screen is to absorb the X-ray beam emerging from the patient body. The ideal intensifying screen would absorb all X-ray energy that enter its really intensifying screen are generally not thick enough to absorb all of the photons. Second, description of film screen system component. As we saw in the image, number 1, base. Clear polyester material about 150 micrometer thick provide physical support of the other film component, does not participate in the image forming process. Number 2, emulsion, active component in which image is formed, typical 5 until 10 micrometer thick, consists of many small, irregular silver halide crystals suspended in gelatin. The silver halide used is typical silver hydrobromide, 10% bromide, 19% iodide. Each grain has a structural defect. Foil in called the sensitive spot. Each crystal is 1 micrometer. Mass sensitive to light energy, therefore intensifying screen use. Number 3, adhesive layer, also called subbing layer or substratum layer, made of mixture of gelatin solution and solvent of film base. It keeps emulsion layer and base adherent to each other during cutting stage and processing. Provide uniform surface over which the emulsion can be coated uniformly. Number 4, supercoat. Protective layer of gelatin provides sturdiness to an exposed radiographic film. Antistatic, reduce damage from scratches, pressure, or contamination during storage, handling, and processing. Third, basic principle. In principle, film is an image converter. It converts radiation, typically light, into various sets of gray or optical density values. An important characteristic of film is that it records or retains an image. An exposure of a fraction of a second can create a permanent image. The amount of exposure required to produce an image depends on the sensitivity or speed of the film being used. Some films are more sensitive than others because of their design or the way they are processed. The sensitivity of radiographic film is generally selected to provide a compromise between two very important factors: patient exposure and image quality. Specifically, image noise. A high light sensitive film reduces patient exposure but decreases image quality because of the increased quantum noise. The main point of the presentation: the screen film is a radiographic receptor, first introduced in 20th century. The component is base, emulsion, adhesive layer, and supercoat. And principal film is an image converter. It converts radiation, typically light, into various shades of gray or optical density values. That's all my presentation. Thank you for your keen attention. Wassalamualaikum warahmatullahi wabarakatuh.